Hello everyone, welcome to the video for CHEMBLAST. In this video, we will discuss question for chapter 3, Electrochemistry, which in this video we will specifically discuss question number 1. Question 1a, the cell notation of an electrochemical cell is given as below. Question 1 Roman, write the overall cell reaction equation. This question have 3 marks, okay? So the tips given is to write down the equation at anode and cathode respectively and combine the equation to write the overall cell reaction equation. Okay, so based on the given cell notation follows the ABC rule, where we have our anode, we have our bridge, we have our cathode. So that is the hint for our anode and cathode. Okay. Besides that, how to determine the anode and cathode is actually based on the E0 cell. Okay, so if the value is more negative, it will become the anode. Okay, so how to know? Remember anode and here, so it will become more negative. While cathode is the more positive E0 cell. So here we have the E0 cell for zinc, which is negative 0.76. and E0 for silver or argentum, positive 0.80 volt. Again, remember anode more negative, cathode more positive. So here is these two values, which we can conclude that the zinc is the anode and the silver is our cathode. Okay, now we have determined the anode and cathode. Okay, so how to write down the equation at the anode and the cathode itself? Okay, so remember, for anode is where oxidation occurs. So what is oxidation? Oxidation where the species will lose electron. Where cathode is the reduction process, where reduction is where the species will gain electron. Okay, so again, before we write down the overall cell equation, the tips given is to write down the equation at anode and cathode respectively. So we're going to write down the equation anode and cathode first. So I'm going to start with the anode, which is the zinc. So at anode, zinc solid will become zinc 2 plus 2 electron. Again, anode is what oxidation occur where we have loose electron. So loose electron must be, the electron must be at the product side. And then make sure the equation is balanced. Here we have zinc only 1 for both sides. Okay, and then calculate the charge. Zinc on the reactant side is 0. So on the product side is 0 as well lah. Zinc 2 plus 2 electron. So positive 2, negative 2 becomes 0. So that is for the anode. Okay, what about the cathode? Okay, so the cathode we have our argentum. So again, cathode is where it will gain electron. So when it will gain electron, the species here at the reactant side must be the one with the charge. Okay, so since here is Ag plus, to make it balanced to form Ag solid, here is charge is 0. So then here must be positive 1 for the argentum itself. Electron must be negative 1. So that is the equation at anode and cathode. Okay, but then based on the tips, we have done the first step. Next, we have to combine the equation to write the overall cell reaction equation. Okay, to combine it to write the overall cell reaction equation, we have to make sure that the electron is the same. In this case, here our electron is 2, here is our electron is 1. So we cannot combine it straightforward. Okay, so what we need to do to make sure the electrons are the same, we have to multiply all of the equation at cathode. We have to multiply by 2. Why? Because we want the electron to become 2 electron. Okay, so I'm just going to write down again the anode here. I'm just going to write down again with no changes at all because we won't multiply or anything. So, but then at cathode that we have to change, all of it will multiply by 2. So here will become 2 Ag plus 2 electron will become 2 Ag solid. Okay, so again for the equation, make sure all the states are written. Okay, so the hint is given as well in your cell notation. Okay, so then we can write down the overall cell equation where we will cancel out the electrons. Since the electrons are the same, then we can write down the overall cell equation. Again, the reactant side must combine to be at the reactant side. the product will combine to form the equation at the product side. Okay, so for the overall, we will have zinc solid plus 2Ag plus aqueous to form zinc 2 plus aqueous plus 2Ag solid. So that is for question 1 Roman. Question 2 Roman. Calculate the standard electrode potential. Okay, and the marks given is 2 marks. Okay, so what is standard electrode potential? Standard electrode potential is the E0 cell. Okay, so what is the tips given? So the tips given is to use the formula E0 cell is equal to E0 cathode minus E0 anode. Okay, standard here, here is our symbol lah, E0. Okay, so based on the first step, we have determined which one is the anode and which one is the cathode. So then we know the zinc will be the anode, the argentine is the cathode. Okay, so we write down the formula. Okay, and then make sure to substitute the value. Cathode is positive 0.80, anode is negative 0.76. So when we calculate it, we will get positive 1.56 volt. Okay, remember, for the calculation, we have to write down the unit, and then for the E0 cell, it is compulsory for you to write down the positive or negative sign. Okay, so that is for question 2 Roman. For question 3 Roman, determine the concentration of zinc ion if the cell potential at 25 degrees Celsius is positive 1.48 volt. Okay, so the concentration of zinc ion is our unknown. Again, if you refer to the cell notation, here it is written down here to be X. So this is our unknown. Okay, so what is the tips given? So the tips given is to write down the Nernst equation. Okay, refer to the overall cell equation to determine the reactant, product, and N. Okay, and then we have to substitute the values to determine the X or unknown. In this case, is the zinc ion itself. Okay, so why do we have to write down the Nernst equation? Okay, because if the question did ask or did give you the cell potential, in this case here, cell potential is positive 1.48 volt, then we have to use the Nernst equation. Okay, because to determine it, we have to use the cell potential. Okay, so what is the difference based on the previous question, question 2? Previously, we did ask about the standard cell potential. So here we have standard. Standard means that we have the E0. So E0 cell is E0 cathode minus E0 anode. So this is the standard one. So first, I'm just going to write down the general formula of the Nernst equation. So for the general formula of Nernst equation, it is E cell equal to E0 cell minus 0.0592 divided by N log Q, where Q is the product divided by reactant. So for the Q, it must be based on the overall cell equation. So here, so that is what is meant by the second sentences. Refer to the overall cell equation to determine the reactant, product, and N. Reactant and product is actually based on our Q here lah. Okay, so N here is based on the number of electron transferred. How many electron do we have cancelled out when we write down the overall cell equation itself? Okay, so this is the general one. So let's look back to what is the overall cell equation for this electrochemical cell itself. Okay, so for the overall, we have zinc solid plus 2Ag plus aqueous will form zinc 2 plus 2Ag solid. So this is the overall one. So I'm just going to write down the formula again, but we have to be very specific. What is N and what is Q? E cell is equal to E0 cell minus 0.0592 divided by 2. Again, because the number of electrons that we have cancelled out, we write down this equation is 2. Okay, log. Okay, so product here, we have product zinc 2 plus and Ag solid. So for the product here and the reactant itself in Q, we will only consider the aqueous or gas state. So in this case, aqueous here, zinc 2 plus is aqueous is considered. Ag is solid, so it will not be written down lah. Okay, but then divide by the reactant. Reactant, again, this one we start with zinc solid, so solid will be will be excluded in the equation, but then we have another one more species, 2Ag plus equals, so here Ag plus to the power of 2 because we have 2 at the front here based on stoichiometry. Okay, so this is the overall cell, or this is the Nernst equation. Then we can do the calculation where we're going to substitute the values to determine x. So what are the values given? Okay, so we have our E cell, positive 1.48 volt based on the question here. The zinc 2 plus is our unknown. Okay, the concentration of Ag plus is 0.05, again based on the cell notation. And the E0 cell is positive 1.56 volt. So again, E cell is the cell potential based on the information from question. E0 cell here is the standard cell potential which we have calculated from the previous question, where the E0 cell equal to E0 cathode minus E0 anode. Okay, so now we have to substitute all the values correctly into the formula. Hence, you will get the value of the concentration of zinc 2 plus to be 1.26 molar. Okay, so that is the solution for question 3 Roman. Question 1b. Magnesium is produced when 12,500 coulomb of electricity are used in the electrolysis of molten magnesium bromide. Calculate the mole of magnesium deposited. So here we have the electrolysis of molten magnesium bromide. So molten, it means it is a melting process from the solid to the liquid. So what we have is MgBr2 solid will become Mg2 plus liquid plus 2Br minus liquid. So again, the state here will be liquid because we're melting the molten process. Okay, so here is MgBr2 because Mg is 2 plus, Br is minus, as we will become MgBr2. And make sure here the equation is balanced as well. Okay, so this is the cation and the anion produced. Okay, but in this case, the question specifically want to know the mole of magnesium deposited. So the magnesium, which is our cation, so cation, the reaction occur at cathode. So at cathode, reduction occur where it will gain electron. So we have to write down the equation. At cathode, the magnesium 2 plus liquid plus 2 electron will become Mg solid. So here it must be the liquid lah, because here it mentioned about melting. When usually we're talking about the electrochemical cell or galvanic cell, usually here is aqueous. But this case, the electrolysis of molten here must be in liquid. Okay. So next is actually based on the equation, then we can do the comparison. Because based on the question itself, it mentioned that the electrolysis of the MgBr2 here will form 12,500 coulomb. Okay, but based on this equation, okay, based on the theoretical, we want to know for 1 mole of magnesium solid, okay, how many coulomb of electric will be produced. Okay. So here, based on the equation, we know that the 1 mole of magnesium is equivalent to 2 mole of electron, where 1 mole of electron is equal to 96 and 500 coulomb. Okay, so in this case, what it's meant is 1 mole of magnesium, we have to multiply this value by 2, which means that the 1 mole of magnesium will produce 193,000 coulomb. So this is for the 1 mole. Okay, so why do we have to find out the 1 mole? Because we want to know what is the mole of magnesium if we have 12,500 coulomb. Okay, so what we're going to do next is actually we're going to do the cross multiplication, and we know that 1 mole of magnesium will form the 193,000 coulomb. And this one based on the theoretical here. How to know the theoretical value? That's why we have to write down the equation lah. Okay. And based on the question itself, we do not know the mole, but we know what is the coulomb. Okay, so now we can find out the X or the mole of magnesium to be 0.065 mole. Since the question only asks for mole, so we can stop until here lah. If the question did ask about mass, then we can find out the mass by multiplying by molar mass. So that is for question 1b. So that is all the video for question chapter 3, question 1.